Okay, good morning to all of you. I am Vishwanath. Today I would like to explain one of the important topic in chemical bonding, hybridization. How do we find hybridization in different chemical species? This topic is very important for JEE mains and NEET. Okay, let us start our topic. How can we find the hybridization using a simple formula, that is H equal to 1 by 2 V plus M minus C plus A. So using this simple formula, we can calculate different chemical species hybridization. In this formula, V is number of valency electrons of central atom. Number of valency electrons of central atom. M is number of monovalent radicals. Number of monovalent radicals attached to central atom. And C is the charge on cation. Charge on cation. And A is charge on anion. So this formula we use it to calculate hybridization of central atom in different chemical species. That means neutral molecules, cations and anions. We hope to understand everybody the terms in the formula. Next we practice some molecules. So I take different chemical species to explain how to find hybridization. Type of hybridization. H value is 2, then its hybridization SP. Like that, H value 3, its hybridization SP2. H value 4, hybridization SP3. If H value is 5, the hybridization is SP3D. Like that, if H value is 6, the hybridization is SP3D2. And H value is 7, the hybridization is SP3D3. So in this way, we using H value, we find out the hybridizations. So we continue the exercise, takes different chemical species after this table completed. I take another molecule, that is boron trifluoride. Boron trifluoride, next molecule. Boron trifluoride. So now we calculate the hybridization of central atom boron in boron trifluoride using this formula. For that, first of all, we write the electronic configuration to know the valence electrons. Boron atomic number is 5, so its electronic configuration 1s2, 2s2, 2b1. So here valence electrons is 3, V value is 3. And number of monovalent radicals attached to central atom, it is also 3. It is a neutral molecule, so cation charge 0, anion charge 0. Now we substitute these values in our formula, that is H equal to 1 by 2 V plus M minus C plus A. So V value 3, M value also 3, C value 0, A value 0. So 6 by 2, finally its value is 3. Already I give a table of H value to identify hybridization. If H equal to 3, its hybridization is SP2. Good. Next we go to another example. that is methane. So in previous example, once again I explained that beryllium chloride, central atom beryllium valence electrons 2, number of monovalent radicals 2, C value 0, A value 0. So substitute it in our formula H equal to 1 by 2 V plus M minus C plus A. 1 by 2, 2 plus 2 minus 0 plus 0, 4 by 2. Finally H value is 2. Then if H value is 2, its hybridization is Sp. So in this way we calculate the hybridization of central atom in neutral molecules. For this we take another example, methane. Okay. Next, the third example is methane. Now we calculate hybridization of central atom in methane. Its formula is CH4. Now we write the electronic configuration of central atom carbon to know the valence electrons. 1s2, 2s2, 2p2. So the number of valence electrons are 4. And here the number of monovalent radicals attached to central atom also 4. It is a neutral molecule, so charge of cation 0, charge of anion 0. Now we substitute this in our formula H equal to 1 by 2 V plus M minus C plus A. So V value 4, M value also 4, C value 0, A value 0. 8 by 2, finally 4. If H value is 4, its hybridization is sp3. So the hybridization of carbon in methane is hybridization of carbon in methane is sp3. Next we go to another example, phosphorus pentachloride. Phosphorus pentachloride. So its formula is PCl5. Central atom is phosphorus. The electronic configuration of phosphorus, its atomic number 15. 1s2, 2s2, 2p6, 3s2, 3p3. So the number of valence electrons are 5. And here 5 monovalent radicals attached to phosphorus. So M value is 5. It is neutral molecule. Once again cation charge 0, anion charge is 0. The formula is H equal to 1 by 2 V plus M minus C plus A. Now substitute the values. V value 5, M value 5, C 0, A 0. So finally 10 by 2 equal to 5. If H value is 5, then its hybridization is sp3d2. Next we go to another example, sulfur trioxide. So I write the H value table here. H value 2 sp hybridization, H value 3 sp2, H value 4 sp3, H value 5 sp3d, H value 6, sp3d2, and H value is 7, sp3d3. Next, take another example, sulfur trioxide. Sulfur trioxide. So the formula of sulfur trioxide, SO3. Central atom is sulfur. Now we write the electronic configuration of sulfur. Its atomic number is 16. 1s2, 2s2, 2p6, 3s2, 3p4. So it has 6 valency electrons. Number of monovalent radicals 0. It is a neutral molecule, so cation charge is 0. Anion charge also 0. The formula is H equal to 1 by 2 V plus M minus C plus A. 1 by 2, 6 plus 0 minus 0 plus 0. 6 by 2 equal to 3. So if H value is 3, then its hybridization is sp2. The hybridization of sulfur in sulfur dioxide is sp2. Hybridization of sulfur in sulfur trioxide is sp2. Okay, next we go to another example. That is xenon tetrafluoride. Xenon tetrafluoride. This formula XeF4. You know the valence electrons of inert gas elements is 8. Xenon is also one of the inert gas elements. No need to write the electronic configuration also to find out valence electrons. If you know group number, then it is easy to know the valence electrons. So your number of monovalent radicals attached to xenon is 4. C value 0, A value 0. Now the formula is H equal to 1 by 2 V plus M minus C plus A. 1 by 2, 8 plus 4 minus 0 plus 0. 12 by 2, 6. So H value is 6, then hybridization is sp3d2. The hybridization of sulfur in SO3 is XeF4. Xenon tetrafluoride is sp3d2. Next I take another example, ammonium ion. Now we calculate the hybridization of central atom in ammonium ion. Ammonium ion. Its formula is NH4 plus. Central atom is nitrogen. Its electronic configuration 1s2, 2s2, 2p3. So the valence electrons are 5 valence electrons. So here hydrogen is a monovalent radical. So its M value is 4. And now it is a cation, C value is 1. positive radicals are called cations. So here one positive charge is there. So C value is 1 and A value is 0. Once again our formula H equal to 1 by 2 V plus M minus C plus A minus 1 plus 0. So 5 plus 4 minus 1 3 8 by 2 H value is 4. So if H value is 4 then the hybridization is sp3. So the hybridization of nitrogen in ammonium ion is sp3. So we take another cation, hydronium ion, and now I explain how to find the hybridization in cations with another example. That is hydronium ion. So the formula is H3O plus, central atom oxygen 1s2 2s2 2p6. Sorry, atomic number is 8, so 2p4. Valence electrons are 6 valence electrons. So already I say hydrogen is a monovalent radical, so M value is 3. C, cation, positive number of positive charges 1, C value 1, A equal to 0. So H equal to 1 by 2 V plus M minus C plus A 1 by 2 6 plus 3 minus 1 plus 0. So 1 by 2 6 plus 2 8 by 2 4. So if H equal to 4 sp3 hybridization. In hydronium and oxygen hybridization is sp3. So the hybridization of oxygen in hydronium ion is sp3. So it is very clear to calculate the cations also. Now we go to next one. Next chemical species, anion. In anions, how we find the hybridization using this formula? We have number of formulas, different formulas, but this formula is very useful and gives good results for different chemical species finding hybridization. So next we go to calculate the hybridization of carbonate ion. Carbonate ion. So its formula CO3 minus 2. Central atom carbon, its valence electrons are 4, its group number is 4. Here there is no monovalent radical. Oxygen is a divalent radical, you know that. So M value is 0. And it have negative charges. So it is anion. So cation value is also 0. And one more important thing, we don't take the sign in this anions, just we take the value only. So here A value is 2. Don't take minus 2. And now substitute its values in this formula. V plus M minus C plus A. H plus 0 minus 0 plus 2. 6 by 2 equal to 3. So H value is 3, hybridization is sp2. Finally, the hybridization of carbon in a CO3 minus 2 is sp2. Next we take another anion to calculate hybridization, that is sulfate ion. So sulfate ion formula SO4 minus 2. Here sulfur also sixth group element. That's why its valence electrons is 6. Oxygen is a divalent, so number of monovalent radicals is 0. And it is negative charge, cation value is 0. Anion, once again remember, don't take sign in this anions A value. Just take only value 2, not minus 2. So substitute these values in formula. It's equal to 1 by 2 V plus M minus E plus A. Six plus 0 minus 0 plus 2. 8 by 2, 4. So H value is 4, then its hybridization is sp3. Hybridization of sulfur in SO4 minus 2 is sp3. I hope everyone understand how to calculate hybridization of central atoms in different species, that is neutral molecules, cations and anions. So next we discuss with another topic in next video, how to calculate the sigma bonds and pi bonds in different compounds. Okay, thank you everyone.